learn something that does not jive with how we think about the world, won't we have to re-examine who we are?
Yeah, it could mess you up. Yeah.
Once again, I'll go back to Oedipus. He plucked his eyes out rather than know anymore.
Yeah, well, people back then, they did stuff like that.
Yes, people back then, not people today.
So I think there are people who would not know, who would rather. I remember the old days. I don't know if it still happens. A doctor would find out if you had cancer, they wouldn't tell you. They wouldn't tell you.
Give it to me straight, Doc.
Yeah, and why would you even have to say, give it to me straight, unless there was a day when they didn't give it to you straight? If I have 5 years left, I want to know I have 5 years left. Because I'm going to, do something different in those 5 years.
Neil?
Yeah?
I have some terrible news.
But
there are some people who don't want, there are some people who don't value science. And if they don't value science, are they valuing ignorance?
Yes, but I will not pass judgment on them. What I will say is, if they are at maximal comfort in their ignorance, fine. Except that they will not be the participants on the frontier of cosmic discovery.
You look at people who are religious today, who are not in conflict with science, they have viewed their religious text as a spiritual, something that gives them spiritual support, not as a science textbook. The conflict in society is when you have those who are still religious, who want to use their religious text as their access point to understanding the natural world. And persistent efforts of the past to make that happen have just simply failed. The Bible does not work as a science textbook. In fact, Galileo knew this, and he himself was a religious man. He's famously quoted as saying, "The Bible tells you how to go to heaven, not how the heavens go." What I want for that, I don't want brave soldiers. I want the intellectual capital of the frontier of chemistry, biology, and physics as my front line. Because I know if we train them for that, they'll come. Now, how do you train them for that? You don't say, okay, why don't you come up and be an aerospace engineer so that you can build an airplane that's 10% faster than the one your parents flew? No, you say, be an engineer, be a biologist, be this, because we're going to look for life on Mars. We're going to look at the chemistry of the center of the moon. We're going to dig for water on Europa. There's the dream. That'll get the next generation of scientists. They're not going to come up just because you tell them they ought to do it. They're going to come up because there's a plan that they can attach their dreams on. And when I stand in front of 8th graders and I want to get them excited, that'll give me something to tell them. And once you have that, and once you're trying to grow crops on Mars in the high iron, low oxygen, low atmospheric pressure, as an example, I'm making this up, but that's as an example, and we ought to combat bioterrorism, where is my frontline biologist going to be drawn from? They're going to be drawn from the biologists who are working on Mars and the research that came out from that. It's the scientists in the silo model, not the bombs in the silo. Forget that asteroid, did she? She didn't forget the asteroid. So you want a quick update on the asteroid. There's an asteroid the size of the Rose Bowl headed towards Earth. It's called Apophis, named for the Egyptian god of death and darkness. Now, it wasn't coincidental that it was named that. When this asteroid was discovered in December 2004, its trajectory was calculated based on a short segment of its orbit, because you look from one day to the next, it's in a new place in the sky. These folks are moving. Once you saw that its trajectory would intersect the orbit of Earth, you don't name that asteroid Bambi or or Tiffany, right? You're going to give it a name befitting its
some sense of gravity.
Yes.
No pun intended.
Yes. That pun was surely intended. The reason why you never heard of it, perhaps, is because it was discovered that this aspect of its orbit was calculated and reported on the same week of the Indonesian tsunami.
Okay, I think it was end of '04 or '05. I forgot which of these 2 years it is. Same week. Odd thing is, of course, 200,000 people died in that tsunami. Odd thing is, if this asteroid hits in a place where it could hit, and I'll describe that in a minute, it will hit in the Pacific Ocean, it would create a tsunami in the Pacific Ocean that would make the Indonesian tsunami look like a street puddle that slightly overspilled its edges. So I think rightly the media attention was given unto the Indonesian tsunami, but that was not an excuse to then never have the press talk about this object. It's a real object. And there's something called the keyhole. It'll have a close approach to Earth in the year 2029, in April 13th, which, by the way, is a Friday. It will come close enough to Earth to dip below our orbiting communication satellites. For that passage, that will be the closest, largest thing we have ever observed in the history of our observing the universe. That's a shot across our bow. The uncertainty in its orbit at this moment is such that for that passage, there is a range of orbits it could have, which if it goes through what we're calling the keyhole, Earth's gravity on it will be just right. Or rather,
Just wrong.
just wrong. That the next time around, it will hit Earth. 7 years later, April 13th. If it goes through the center of the keyhole, it'll hit the Pacific Ocean 500 kilometers due west of Santa Monica. It'll plunge into the Pacific Ocean to a depth of 3 miles. At that depth, it will explode, cavitating the ocean with a hole 3 miles wide, 3 miles deep. That impulse will send a tsunami wave that will basically wipe out the entire west coast of the United States and the east coast of Asia. Now, oceans don't like having big holes in them. So this 3 mile high wall of water does what? It's a hole in the water. What does it do? Falls back in the hole. This is not Moses here. We're talking. It won't just stay there, like in the movie. It'll fall back into the hole, slosh into itself, rise high into the air, fall back to the ocean, cavitate the ocean again. And it'll do this with such ferocity, it'll repeat itself about 50 times, taking about an hour. So every time it cavitates the ocean, it sends another tsunami. So it won't be just one wave like the Indonesian tsunami was. This will be 40 waves, 50 waves. Now, each wave has to pull back out to get ready for the next one. And they're separated by about a minute. So there's a limit to how far these waves will get on shore. We think it's about a quarter of a mile. So if you're more than a quarter mile inland, you can just watch this happen. If you're not, now, the $1 million Malibu homes, they will feel this first tsunami wave. And then that tsunami will basically pick up the homes. It'll bring them back out to sea. Then the next wave will come and return the home to the shoreline. But now the home is in a slightly different shape. And as this continues, all man-made objects along the coastline and trees and debris basically becomes this churning, ablative mass, wiping clean the entire coastline. Now, nobody has to die, because we'll know this well in advance. The ingredients of life as we know it match almost one for one the ingredients in the universe. For me, the most profound fact of my life. Go right on down the list. Hydrogen, oxygen, carbon, nitrogen, right on down to iron. They're also the most common ingredients in the universe. These heavy elements are traceable to the exploded remains of one or more massive stars that forged these elements in the core by the action of thermonuclear fusion. These stars then blew themselves to smithereens, giving their lives to enrich the galaxy with the manufactured heavy elements from their core, enabling planets and people to form. Here we have a view of a supernova remnant in the constellation Vela, one of my favorite images of the cosmos. This ejected material will enrich gas clouds that will make solar systems. Yes, we are stardust. It depends on what you mean by see. If you broaden the notion of see to finding evidence that supports it, the answer is yes. We see back to several 100,000 years right after the Big Bang using visible light, using light from the electromagnetic spectrum, and that's this microwave evidence that I described earlier. Because before that in time, the universe was opaque to the transmission of light. But there were things that happened before then. For example, there's a period where neutrinos were released, this ephemeral particle that's very hard to detect. If we whipped out a neutrino telescope that had very high sensitivity, you could see farther back in time to the first few moments of that explosion. If we perfect our gravity wave detectors, you can see even farther back to gravitational episodes at the very first few moments. And so, like I said, as you look farther out in space, you are looking farther back in time. And at a 13, 15 billion year old universe, if you see that many light years away, you are seeing the evidence of the Big Bang. So the answer is yes, and it continues to be supported by data, much to our amazement and joy, actually. It's one of the triumphs of our models of the universe. When you think, for centuries, people have tried to wonder how we got here and what the origin of the universe was, and it was only in the last several dozen years that we've had scientific data to answer those questions, to be something more than just mythology. Closer to the sun, has a thick, seething atmosphere checking in at 900 degrees Fahrenheit, which is not only hot enough to melt lead, but more important, it's hot enough to cook a large pepperoni pizza in 9 seconds. The Venusian atmosphere is hostile, nearly 100 times the pressure of Earth's atmosphere. It's made primarily of carbon dioxide, upon which we can blame its runaway greenhouse effect. Mars was probably once a paradise, an oasis of running water, with an atmosphere dense enough to support it. No longer, it is bone dry. Only relic riverbeds and floodplains and silent river deltas remain. Yes, bad things happen to good planets. Mars and Venus may be the endpoints of climactic evolution gone awry. How do we prevent our cherished world from becoming another casualty in the solar system? By combining cosmic discovery with the earth sciences, our insights may offer us more than just fulfillment of our idle curiosities. Our insights may enable us to save ourselves and to perhaps get to know our planet for the very first time. Thank you.
Still happens. A doctor would find out if you had cancer, they wouldn't tell you. They wouldn't tell you.
Give it to me straight, Doc.
Yeah, and why would you even have to say, give it to me straight, unless there was a day when they didn't give it to you straight? If I have 5 years left, I want to know I have 5 years left. Because I'm going to, do something different in those 5 years.
Neil?
Yeah?
I have some terrible news.
They will not be the participants on the frontier of cosmic discovery.
You look at people who are religious today who are not in conflict with science. They have viewed their religious text as a spiritual, something that gives them spiritual support, not as a science textbook.
If we learn something that does not jive with how we think about the world, won't we have to re-examine who we are?
Yeah, it can mess you up.
It can.
Yeah.
Once again, I'll go back to Oedipus. He plucked his eyes out rather than know anymore.
Yeah, people back then, they did stuff like that.
Yes, people back then, not people today.
So I think there are people who would not know, who would rather. I remember the old days. I don't know if it's
but there are some people who don't want. There are some people who don't value science, and if they don't value science, are they valuing ignorance?
Yes, but I will not pass judgment on them. What I will say is, if they are at maximal comfort in their ignorance, Fine. Accept that.